In the last video, we looked at zero exponents. Let's see what happens when we deal with negative exponents. They've shown up a couple of times in our last videos. So what does that mean to have a negative exponent? And a negative exponent does not mean that the whole answer is negative. So negative exponents don't mean it's not that the answer is negative. Answer is negative. Answer might be negative, but it might be positive. The negative exponent has nothing to do with the value being positive or negative. What the negative exponent does mean is to write the reciprocal. So if you see a negative exponent, you know that you are going to be writing the reciprocal. So let's do a couple of examples of that. Say we have 3 halves raised to the -2 power. What that means is to flip the 3 halves, so it becomes 2/3, and then you change the exponent to positive. So if I have 2 to the -5th power, that means write the reciprocal. Well, what's the reciprocal of 2? Right? You could think of that as 2 over 1, and the reciprocal would be 1/2. So 2 to the -5th is really 1/2, and then we want to change that negative exponent to positive 5. 1/2 to the power of 5. What if it has a mixture of things? What about x to the -2, y to the -3? Well, let's see. The x to the -2, that becomes 1 over x squared. And y to the -3 becomes 1 over y cubed. So I can also think about negative exponents as moving whatever the base is to the other side of the fraction bar. To the other side of fraction bar. So if I started off with something in the denominator, like maybe we have 5 up here on the top, and then a y to the -3, and maybe x squared. This guy right here, the y to the -3, I'm going to move him over the fraction bar to the top. So it just doesn't mean move things into the denominator. It means negative exponents mean move those variables to the other side of the fraction bar from wherever they've started. So this guy is going to become 5. I'm going to move the y up top. So now it's y to the +3 over x squared. Let's take a look at a couple of examples on page 91. They're really pretty good. Maybe start off with number 24. Get a new piece of magic paper here. So number 24 on page 91, w to the -2 over w to the 6th power. So, yep, I could absolutely think about this as division rules, quotient rules, and do the subtracting. So I could say that's going to be w to the -2 minus 6. That's one way to think about it. If I did that, I would have w to the -8. And then I've got this negative exponent, and negative exponents mean write the reciprocal or move stuff over the fraction bar. And you may be saying, well, where's the fraction bar? There's no fraction bar there. Well, let's draw it in, right? Anything can be written over 1. So there it is. There's your fraction bar. Now I can move the w over it. It's going to end up in the denominator. So my answer is going to be 1, right? There's nothing left up here if I move the w to the +8. So I could think about that using the quotient rules. So quotient rule. But I can also approach this problem by thinking about negative exponents. So w to the negative 2, that's a negative exponent, and I could move this guy over the fraction bar. Let's move him right down there. So let's do that. So now I've got a 1 left in the top. I started off with a w to the 6 in the bottom, and now I've got a w squared in the bottom. Remember, when you move that variable over, you're changing whatever the sign is. In this case, it's negative, changing it to positive. So now I'll use my product rule. Product rule. We've got 1 over w to the 6 times w squared is really w to the 6 plus 2, or w to the 8th. And look, we've got the same answer. Thinking about it two different ways. Let's try another one. What about number, let's do number 10. So number 10 is 9 cubed times 9 to the negative 1. We'll start off using the product rule. Let's just go ahead and add our exponents together. So 9 cubed is 9 to the 3 plus a negative 1, which is just going to be 9 squared. So that's one way to think about it, right? Just using product rules. But I could also use negative exponent rules. So 9 cubed times 9 to the negative 1. Here I've got a negative exponent, right? So I can put a 1 down on the denominator, and then I'm going to move, not just the negative 1, I'm going to move this whole thing, the 9 to the negative 1, down into the denominator. So I still have a 9 cubed on top, but now I've got 1 over 9, or 9 cubed over 9, and then I could think of this as just canceling. 9 times 9 times 9, that's 9 cubed in the top, plain old 9 in the bottom. Cancel out that factor of 9, and I end up with 2 9s, or 9 squared. So two different ways to think about the same problem now that I understand what negative exponents are.